All right. I think there'll probably still be a few more people joining, but we've waited a couple of minutes into the hour. So it's a real pleasure to welcome Yun Ma as our Centre for Global Wood Security speaker today. Yun Ma started out doing his PhD in the Chinese Academy of Sciences, where he worked on forest landscape modelling and thinking about the impacts of downstream impacts of climate change. And then, having graduated in 2015, he moved to Fudan University, based in Shanghai, where he worked with Shan Ming on land use and land cover mapping. And then subsequent to that, he's taken up an associate professorship of landscape ecology, remaining at Fudan University. And as kind of the introduction's already kind of pointed, Yun Ma's real contribution is at this massive landscape scale thinking, in particular about the kind of tensions that are occurring within landscapes between farming, between forestry, and the kind of disturbances that happen through fragmentation. And then taking that massive landscape scale thinking and really starting to model what the impacts are for biodiversity or ecosystem services. And so with that, Yun, it's a real pleasure to have you speaking today, and we really look forward to your presentation. Thank you.
Thank you, David. Thank you. Hello, everyone. I'm very glad to be here to give a presentation. And my name is Juma, and just as David introduced, I'm an associate professor in Fudan University. So, yeah, even David has give a short introduction of me, but I still want to have a brief introduction of my group. And our group is mainly, I gave a name, landscape ecology and ecological remote sensing. So we mainly explore the interrelationship between landscape pattern dynamics and ecosystem processes. So we are mainly focused on forests and coastal wetlands. Okay, let's focus on today's topic, forest fragmentation. So what is forest fragmentation? According to Reuters, we can have a definition of forest fragmentation. Forest fragmentation refers not only the loss of forest area, but is also the division of the remaining forest patches. So why forest fragmentation important? Because forest fragmentation can have many effects on affects the habitat and have many negative impacts on the biodiversity, and it can also affect the carbon sequestration and the microenvironments. So forest fragmentation has a high or very deep influence on the ecosystem. So today I will give my presentation from the three aspects. And the first is I would like to share our work in previous years, and it's on the assessment of the forest fragmentation. So our big questions is how to map forest fragmentation. So a lot of previous studies have reported that the world's forests are facing severe fragmentation, and they has also give us some maps about the forest fragmentation. For example, the last one is a paper in Nature Communications in 2021. We find that they reported that the tropical forests are more intact, but the forests in temperate zones are more fragmented. Also, this result also presented in Haddad's paper in Science Advances, and they believe the most intact forests are located in the tropical regions. But there has some problems in their assessments, because they mainly from a static view or static perspective, but just based on our based on the definition of forest fragmentation, it is a process, but not a status, a static status. And also, in the previous studies, also focus on one feature or one characteristic of the fragmentation, but fragmentation have many aspects. For example, from this one, from the big forest in a big forest patch into several small patches, the patch numbers will change, and the edge density or edge length will also change, and yeah, and the connectivity will also change. So there are different characteristics. So we should include more features in the forest fragmentation assessment. So we do a work. We mainly use the forest maps from Hansen's lab, and we use the global net cover, and then use the dataset, and it has the forest maps, and we use the two maps. One is for 2000, another is for 2020. And based on this map, we gave a definition of forest landscape. Yes, I mainly research landscape project because I would like to give a definition of forest landscape. We use a 5 kilometer size grid to calculate forest coverage, and if the forest coverage is larger than 30%, I will regard this grid as forest landscapes. So in this forest landscapes, we can calculate some index related to fragmentation. So which index or which indexes should we consider it? And we mainly consider three aspects of the characteristics of the forest fragmentation. And just as I mentioned before, so we choose the edge density. It is mainly like this one, more edge emerges, and the patch density. For example, this one, previously before the forest north, it is one patch, but after the forest north, it becomes the two patch. So patch density will change, and also the mean patch area is also reflects the loss of the area of the loss of forest. So I combined the three characteristics of the forest fragmentation, and we just use the mean value of the three different indicators. But before this, we do a normalization for all the value globally. So, but especially for the mean patch area, because it is a positive line with the forest cover, but the other two are negative correlated with forest cover. So I use one minus the result, and finally we get the forest fragmentation index. We call it FFI. So I can calculate the static FFI for 2000 and 2020. And we also can have, from a dynamic perspective, we use the delta FFI using FFI in 2020 to minus FFI in 2000. So we can see the results. These two maps are forest fragmentation in 2000 and 2020. We can see our results is aligned with the previous results. We find that for example, in tropical areas, especially in South America, in Amazon, in the Africa or in Southeast, in tropical rooms, the forests are more intact. But in some temperate areas, for example, in South China, in the Europe, or in the US, they are more fragmented. So the static forest fragmentation index is really like some results presented in previous studies. But when we look at the dynamic one, look at the dynamic forest fragmentation index, we can find the results are totally different. we can find in the tropical, the most intact forests are experiencing the most severe fragmentation. We can see the red color means the fragmentation level are increased, and the blue color means the fragmentation are decreased. So we can see tropical regions are experiencing more severe fragmentation. And from the statistical results of the delta FFI for different climatic zones, we can find the only positive value, mean value, are emerged in tropical regions. But for subtropical, temperate, and the boreal areas, they are all or minus or negative values. That means for the globally, most of forest landscapes are becoming less fragmented. So about the proportion is about 75%. Yeah. So after we get the map of the forest fragmentation, we would like to know how it happened, why it happened. So we do some drive force detection. We use a larger size of grid to about the 10-kilometer grid to do some non-linear relationship to do some machine learnings using to track the relationship between these factors with the forest fragmentation index. We can find that in the boreal regions, especially in Canada, in North Canada, and in some regions in the Southeast Amazon, and especially especially in Australia. Yeah, the forest fragmentation are mainly caused by fire. But for some other regions, some like the East US, the Europe, and the East Asia, including China and Japan and South Korea, these regions are more economic developed regions, and the fragmentation there are mainly caused by some factors related to nighttime and night and cropland, and these factors are mainly highly related to human activities. So we conclude that human activities are main cause of FFI change in these regions. And also we can see some when we zoom in, we can directly see the forest map in 2000 and 2020. The update is 2000 and this is 2020. For example, in this point is a grid, is a landscape, is a forest landscape. It's mainly located in the Amazon. We can find in 2020 the almost the full of forest, but in 2020 a lot of forests are lost, and we can just see from the edge, the straight edge. That means that it is really the forest is lost by human logging or harvest, or I think this area is the forest is lost by human by some commercial harvest maybe. And we can also see some point in China, for example, the D3, the decrease. In this one, the fragmentation is decreased, and this one in this region, China has implemented the large-scale forest restoration. We can see the forest coverage is increased, and yeah, so the forest landscape is also increased. But for some regions, it is also different. For this one in Canada, we can see the forest area. The forest area actually is a night decrease, but also but the fragmentation level is also decreased. So it is very strange or very special to know the change of forest cover is not always aligned with the change of forest fragmentation. So based on this phenomenon, we establish a framework, a two-axis framework based on the forest coverage and the forest fragmentation. So we divided all regions into 4 types of patterns. For example, in pattern 1, the forest coverage is increased, but the forest fragmentation is decreased. That means the more forests are introduced and the forest fragmentation is decreased. But we also have some patterns too. For example, for this too, and we can find that when sometimes the forest coverage increase, but the forest fragmentation also increase. That means that is actually sometimes like in some regions, people are planting trees or forest restoration, and the new forest patches are introduced. So they may increase the edges or increase the patch numbers. So they will finally cause the forest fragmentation increase. So we cannot to give a assessment or give a evaluation of the forest landscapes only based on forest coverage or based on forest fragmentation index. We should combine these two. So we can find, yeah, at this this result, they can find the first one, the pattern 1 is the best one, and oppositely, the pattern 4 is the worst one. So the forest coverage declined, but the forest fragmentation increased. That means the forests are mainly indicate the forests are it goes into a deep degradation stage. So we can find that the worst one is the brown, with the brown color. We can say they are mainly located in tropical regions. But we should also make awareness or some align with this one. This one is the pattern 3. Pattern 3 is forest fragmentation. Forest coverage decrease, but forest fragmentation also decrease. That means when sometimes some small forest patches are lost, but the forest fragmentation index are decreased. But actually, this is the early degradation stage, so we should stay aligned of this kind of pattern. And based on that framework, we also calculate the delta for FFI with calculate the relationship between delta FFI and the delta FC. We can find they have a very good relationship, linear relationship. So that means we can when enhancing forest area is still an important way to mitigate the forest fragmentation, especially at the national scale. So yeah, this work is we published in 2023, and all the FFI data we make them open publicly. So secondly, I would like to introduce another research about the impact of forest fragmentation on ecological processes. So many studies have reported the fragmentation's impact on the carbon sequestration, and the forest fragmentation's impact on the carbon is mainly this process is mainly caused by the edge effects. So we can see in the forest edge there will be more the higher wind speed, the more in the edge it will be more drought and more fire or some other disturbances. But these factors will cause forest or tree growth have a negative impact on the tree growth. But in the edge, we will have more. It will have more sunlight and the nitrogens. So, and these two factors may have a positive impact on the tree growth. So there are a trade-off environmental benefits of tree growth in the forest edges. So, although some previous studies have reported that, especially they find that in tropical forests, the forest edge carbon relationship, they normally display a negative relationship. But in temperate, some studies, this group in Boston University, they reported that in temperate forest there were always positive the edge carbon relationship. But we want to know what is the spatial pattern of the forest edge carbon relationship, because in this study, in these two studies, they were mainly using the forest inventory data based on the forest plots, but they never give us a map of the relationship of the edge carbon relationship. So we would like to do this thing, and at this time we focus on the United States and the contiguous United States, and we also use a data set, and as we used in our Nature Communication paper, and yes, we also use when we use the forest carbon data. We would like to use the annual MPP, the net primary productivity, as carbon sequestration or the carbon uptake data. So, and we do our analysis at two scales. One is the 2 kilometers grade. In this grade, we calculate the ratio of edge forest to total forest. This means this index will reflect the proportion, the level of the edge effects. And we also calculate the annual MPP, but this MPP is only for forests. And for each 2 kilometer grade, we have the ratio of edge forest and the MPP data. So we can do some simple linear regression. So if the forest edge, if the edge effects have a positive impact, so with the edge proportion increase, the MPP will increase. So the slope value of the regression line will be positive. But if the edge has a negative impact on the carbon, this regression line will be like this. The slope value will be negative. So we calculate the negative the slope value for each grade, for each 20 kilometer grade, and we find a very interesting result. In the if we find the yellow and the red or the brown, the color means that there will be positive edge carbon relationship. That means the edge effect will have positive impact on carbon uptake, and this relationship mainly occurs in these regions. And yeah, I'm not a American people, but I know these areas are mainly flat areas, a Mississippi River basin, and this is also very plain areas, but for the negative relationships, they are mainly emerged in some mountain areas, some Appalachian Mountain, and in the Western Mountain areas. So this result will remind us to guess the topography may have a great impact on the edge carbon relationship. But in previous studies, they find that they have two papers about to report that the forest in temperate rooms, in temperate areas, edge will have a positive on the carbon. And from all the results, we just make a statistic. We find that when the edge ratio is higher than 40%, and we find that is more the forest more near to edge, and will have a higher MPP. This means that the edge will have a positive impact on this. So we guess they were mainly their plots were mainly located in this area, but they neglected these areas results. So, and yeah, this is and so just based on the results, we find that the topography may have great impact on the edge carbon relationship. So we do a check, and we use the topographic data, the digital the DM data, and we use the DM data and as the altitude, and we use the standard deviation value of the DM as the relative amplitude. It means and we use the DM STD to define. We divided all areas into three type of topography types. One is rugged, and it means that the DM STD larger than 100 meter, and one is flat. So the DM STD will less than 10 meter. So we can see the results, and we can find a very good relationship between the edge carbon relationship. This it means the slope value of the linear regression, and the x-axis is the relative aptitude. We can find them. They have very good relationship, and R square it equals almost 0.96. And we can see, and also when they see the different types of the topography, we can see for rugged areas, most they were displayed the very high negative impacts of the forest edge on carbon, but for flat areas, the result will be positive, and they were totally significantly different. And we can see their compositions. And for rugged areas, we can see about 96% are grids, or 96% of the forest landscapes show negative impacts of edge on carbon, and among them, about 85% are statistically significant. But for flat air regions, the about more than 50% show as the positive impact of edge on the carbon. So that is we know that so from this we know that the topography will have a very deep impact on the edge carbon relationship, but we don't know how it impacts. So we would like to do some mechanism exploration. So when we look at the carbon uptake processes, we can see when a tree, when a forest, the axis is the time, the y axis is their daily productivity. We can find their first increase and then reach the peak and decrease. So the area of the gray color means their annual productivity. So these they are controlled by two factors. One is the carbon uptake period, it's the length of the growing season, and another is the maximum daily GPP, or maximum daily productivity. So if the topography affects the forest productivity, they are either by phonological, is by the length of the growing season, or by the physiological process, it means by the maximum daily GPP. So based on the results, based on the map of the edge carbon relationship, we choose several hotspots. For A and B, they were mainly in flat areas, and they have a positive edge carbon relationship. We can find that they were mainly the edge's influence are mainly worked by through the physiological process, because they increase the maximum GPP, maximum productivity. But for some hotspots in the west, they are mainly in rugged areas, and they were showing negative EC edge carbon relationship. And at this circumstance, the carbon was impacted by two were at the same time. They were impacted by the phonological and the physiological at the same time. So So we guess we have a hypothesis that in flat area, more dense and small trees are more likely grows in the forest edge. So they will cause higher maximum daily productivity. So because high young trees have higher productivity. But in rugged area, and we conclude that we guess that we may be weak canopy and the simple species compositions in the forest edges. So and also the lower maximum daily productivity and less growing season days, they will influence on the tree's growth. But this was not confirmed by the field data. So we do some field plot survey and monitoring in China, also in some forest areas in China. Yeah, we make some monitoring of the tree growth and to monitoring the microclimates, the soil moisture and the temperature of the soil and the temperature of the air. Yeah, but this is still an ongoing study. Okay, well, I will be quick. And the last, I will give some introduction about our recent work about the forest restoration and some forest restoration we are partially in response to or in order to mitigate fragmentation. And yeah, and forest fragmentation is recognized as one of the most cost-efficient, effective, and scalable nature-based solutions for climate and or for biodiversity maintenance or biodiversity conservation. And some activities such as born challenges and highlight the importance of the restoration of forest. So when we get during the forest restoration, we find that the spatial optimization will be very important because, for example, in this area, if we plant the trees in this area, we can connect this divided the patches, and we can get more intact, more continuous, and more connected forest patches. So special patterns, so the special will be very special optimization will be very important. So in this study, we focus on China, and because China has historically led the world in the forest restoration efforts and has ambitious future goals. So we would like to ask to answer three questions. And the first is, will the most successful restoration in China? Second is, where are the priority areas for the future? And the third one is, how does spatial optimization perform? Whether the spatial optimization will have better results. So yeah, I will give brief introduction. I will directly give the results. In China, we have do some. We use the forest fragmentation. Mainly use the remote sensing data. We find that for individual, for some, we considered three individual benefits. One is the habitat conservation. We just use the mean patch area, and it is also one of the fragmentation index. We use their change as habitat conservation to assess habitat conservation, and we also use the carbon stock and the change. And this change is only only produced by forest area, but not by forest growth. So we do some work, but I'm not showing here. And the forest for when we planting trees or forest restoration, we will have impacts on the temperature. So we using the temperature, the change of temperature as a climate regulation benefits. So we can find that for each individual benefits, for example, the habitat conservation, we can find in Southwest China, it will have a better performance. But for multiple benefits, yeah, we can also find for this one is habitat conservation plus carbon sequestration. And we also find in South China and the North East, they are both bad, they are both good. But for all the three benefits, we can find the Southwest will be a successful forest restoration. And we use a GBM model to detect the driving factors of the restoration benefits, and we mainly use some environmental factors, and for example, some factors including climates and some topographics, and some the initial state of the forest coverage. We find that forest coverage was the dominant factor influencing the combined benefits. So we can conclude that when we planting trees, the afforestation near existing forests, it will be more easier to make the new trees survive, and it will have higher ecological value. And this is we ask several local people, especially in Western China, in drought area. They they agree with they agree with this, and they believe they believe afforestation near trees are more is a good choices. And in the future, and we do a simulation based on the model of the restoration benefits with and the environmental factors. We do a simulation for the future. We can find that most of the A, B, C, they were individual benefits, but D, E, F, they were combined benefits. For example, in F, all the three benefits combined together. We can find in the Southwest, has the highest priority for the future forest fragmentation, forest restoration. Sorry. And in China, because in China we have set a lot of forest goals, forest coverage goals, and the latest the China's forest coverage goals was will cover 28.1% of the whole China. So that means, but now we have we have do some calculation of the forest coverage into forest areas. So we can get the result that a gap of about 49.5 million hectares we still need to restore forest at this area. But for how at this time we would like to check if we to restore forest at a uniform region. It means that you can restore forest at anywhere and at the same time, and another scenario is that we restore forest based on the priority map. For example, based on each priority map, we can get different results. We can find them if we use a uniform restoration scenario, and the goal will be achieved in 2046, and we regarded the benefits of at that time as 100%, and we calculated the all three benefits combined the target. If we can see that if we use the special priority as the basis for our forest fragmentation, we can either reduce the time of the forest coverage goals by at least 5 years. We can as early as in 2041 we can get all three benefits more than 100%. But if we don't want to achieve this time, but if we still want to plant more trees at the 2050, we can get that the benefits of different targets will be increased, and the at least increased by 12%, but for the climate regulation benefits, it will be increased by about 50%. Okay, I will give a short summary, and today First, I give a assessment of the global forest fragmentation trend, and we conclude that the 75% of global forest landscapes are showing reduced fragmentation trends. And another is the increasing forest area is an effective strategy to mitigate fragmentation. And as to the impacts of forest fragmentation on carbon sequestration, we can find them the topography factors controls the forest edge carbon relationship. And as to the implications for forest restoration, we can see that the spatial optimization can improve multiple ecosystem functions, and if we use spatial optimization during future restoration, we can get better results. Thank you. Thank you all. I would like to discuss with you. I'm sorry I took a certain amount of time to give the introduction.
Not at all, no. It was roughly a 40-minute talk, and you gave a 40-minute talk. Thank you so much, and lots of a round of applause virtual on your screen.
Thank you.
So we have about 15 minutes for questions, and people are welcome to put up their hand or to type a question in the chat box, and I'll read it out. Yiping, you've got your hand up, so I'll let you go first. Thank you.
Yeah, thank you for a really interesting talk. And I was wondering about the last research you do about spatial optimization of restoration. I was wondering if you have thought of including assessment of the cost of restoration, both including implementation costs affected by things such as accessibility and opportunity cost, such as like its original agricultural production value.
Yeah, very good question. And actually, in this study, we don't consider the cost, including effective cost or the real cost. And actually, we know in this study, we only based on the benefits of the forestation, mainly the ecological benefits. We don't include the cost. But actually, a PhD student is working on the cost, and we would like to, yeah, we may have some new results. Thank you.
All right, thank you, Yiping. John Healy.
Thank you very much, John. That was so much in 40 minutes. It's hard to assimilate all of that. But I was particularly interested in the second part of your talk on impacts of forest fragmentation on carbon sequestration relating to topography, because I've spent so much of my time researching in mountain forests. I've got several things I'd like to communicate with you, but I'll just restrict myself to one of them in a question. Maybe I put others in an email or something. So I'm interested in the source of your productivity data and how those data would have treated tree mortality or severe damage. Because I would imagine that on steeper, well, not imagine, I know that on steeper slopes you have higher rates of various sources of damage, just basic gravity, wind, fires blowing up slopes and so on, which may particularly affect edge trees to a much greater extent than edge trees in flat areas. So to what extent do you think the damage, mortality and so on was included or excluded from the measures of productivity that you use?
Yeah, very good questions. Thank you, John. And yeah, actually, in this study, in our analysis, we cannot consider the tree death or tree recruitment, and because we mainly use the net primary data, net primary productivity data, and this we use this data because it has a very high resolution, spatial resolution at 30 meter. And I know this data is produced using a night efficiency model, and I know it is not considering the death or some disturbances of the, for example, the wind or the fire or some human activities on the tree deaths or on the forest on the afforestation maybe. But yeah, so that is only, this data are only from remote sensing. So using remote sensing, we cannot get some detailed informations. But actually, as you mentioned, it's very important when we in the mountains and the forest in the mountain, they are facing different environmental conditions. So yes, just because this, we do some monitoring in the field, and we are doing some yeah, we're doing some transactions from the edge to the interior, and it's in southwest in southwest China, in Yunnan, and we would like to get the monitoring result, and maybe next time I can share this result. Thank you, John.
Thank you. Now we have a question from Shahab Ali.
Hello, first of all, I'm very thankful to Professor David who gave me the wonderful opportunity. And my question is from June. It's not a question, but I think I want to understand that as compared to tropical region and temperate region, there is a lot of differences in terms of climatic condition, as in the tropical region, the temperate region, the climatic conditions are very different. And is there any role of the geological processes in the forest fragmentation as compared to the tropical region? Because in the temperate region, there is a lot of mountains. And so is there any role of geological processes in the forest fragmentations? Like they are naturally fragmented, or they are like they are naturally fragmented due to the geological processes, or there is any other like phenomena or involved, that is climatic or topographic or something like that?
Thank you, Shahab. Actually, you are right. We, based on this analysis, we also do some similar work in the tropical regions. But in tropical, we don't have very fine solution maps for the carbon, or for especially for the carbon, for the prime MPP data. And we use the 500 meters resolution data, but we don't get the similar results. And the topography or the geographic, they don't have impact on the edge carbon relationship. But I'm sorry, I have never been to in the tropical forest. I don't have the very, I can't imagine. Because I have never been to there, so I don't know something. Maybe I can't understand whether the topography has impact on the environment. I know in tropical regions we normally have the dry season and the wet season. And so, and based on some studies, they reported that they reported that in tropicals, the most of their findings they have negative effects of the edge on the carbon. And I think maybe they are mostly controlled by the water condition, and maybe by moisture. I'm sorry, I don't know. I just make a assumption.
Yes, that's okay. Thank you so much.
Thank you.
Thank you. Sinran, you have a question? Simran, you're on mute. Simran, you have to unmute your microphone.
Can you hear me okay now?
Yes,
Yeah.
I can hear.
Okay, so thanks for the great talk. I have two questions. One is for the first section regarding to the early stage restoration. Early stage restoration may lead to some increase in fragmentation. I'm curious about this because I'm looking at the agroforestry, which is also a kind of very important restoration approaches. And I think the late stage restoration is still a composition of forest and cropland. So this might need to be not considered as early stage recovery, probably. And also for that kind of restoration, um, uh, uh, when you calculate the fragmentation index for this, how to say, did you identify the fragmentation as originally is native forest and change to and be fragmented, or from a cropland comes to some patches of tree growth can be identified as fragmentation as well?
Thank you. A very good question. Actually, we don't differentiate the natural forest or the plantations. So that is a very important. It is a big problem during our submission of the paper, and as I know, maybe because as for the four patterns of the forest dynamics, the different stages. It's just we just to make some possible explanation of their patterns. And for example, I just mentioned in the forest when the agricultural land expanded into forest, and I think they may first to replace the forest, the small patch as small patches, and then when the small patches are all excluded, and they can to encroach in the large forest patches. So at the very early, so that will be the two different stages. The one is the early degradation when the exclude, or when replace some small patches of forest, small forest patches, and the forest coverage, the forest area will decline, but the forest fragmentation index will also decline. So maybe we'll give some our wrong results or some wrong indications. But so the pattern 2 and the pattern 3, they are not normal. They are very different because the change of the fragmentation and the change of the forest cover, they are not at the same direction. So in our paper we discussed that we should pay more attention on these two patterns, because we can easily change it or restore forest at the early recovery stage, but we can easily make the early degradation stage into the deep degradations. So that is easy. Or if we converted all the pattern 3, the yellow one into the brown one, so we can find that most of our forest will be deep degradation. And that is just a possible discussion, and we don't have the direct evidence to confirm our assumption, and maybe in the future, and we can do some detailed works. But I think it is a little hard to do this work at the globe scale. Yeah, thank you.
Great, thanks very much. And if I may, I have another question regarding to the third chapter. You look at the restoration benefits from China. I'm curious about the restoration landscape at the real restoration landscape or its potential landscape, and which kind of restoration type was used on this kind of landscape?
Yes, actually, we just because we do this because we want to do a lot of studies. We do the future restoration potential area, the potential regions for the future restoration. We based on the species, the tree species, we modeling whether the tree species can survive or in a place, but we believe we should focus on the history because China has forest. China restored forest since in 2007, and we have at least 20 years history to give us some evidence. Or we so based on this result, we find that we just use the forest cover, the cover of the forest changes, and we find there will in which places they perform better. So we find in different regions they have different benefits. But actually in this study we also have some problem because we only consider the three benefits. One is habitat conservation, and another is carbon and climate. But but a lot of the forest can benefit us at more aspects. For example, they can reduce the wind and sandy, and so that is why in the northern China, especially around Beijing, they are not have a good performance, but actually their biggest benefits we are not included. So that is maybe the biggest reason.
Yeah.
Okay,
Thanks very much for this.
Thank
Maybe
you.
you can.
we're going to take
Thank
one quick question from Jianjing, and then we'll close out.
Hello, thank you for your wonderful report. Why do you consider the influence of DEM? What is the implications? Because fragmentation has many other impacts, such as biodiversity.
Yes, and first, in this study, we would like to check the edge effects or the forest fragmentation's influence of forest fragmentation on carbon sequestration. And because some previous studies have reported that in the tropical regions, there mainly have elective effects, but in the temperate, some people reported the positive effects of edge on the carbon. And but I'm more familiar with temperate forests, so we do some analysis using remote sensing data. And from this result, we can see that the map is very interesting because the positive ones are mainly located in this region because in the research, I know that in these regions, they are plain or they are very flat, and from this map, I guess I just a guess. I guess from the topography maybe have significant impact. So I detect I want to explore the assumption, and and as to the topography, one is the elevation, and another is the change of the elevation. So because I have been to US for many times, I'm a little familiar with this region, so I think it's more the mountains and the relief aptitude may be more important. So I test my hypothesis, and it's just as I guess the results shows that the topography is especially the change of the elevation may have more higher impacts.
All right.
I'm sorry.
I think we're going to have to leave it there. Thank you. I just, before we say our final thank you, Yun, I just to say that the 10th seminar will be on the 5th of February, and that will be Professor Tony D'Amato from the University of Vermont, who is a professor of civiculture and forestry sustainability. With that, really thank you so much, Yun, for a really thought-provoking talk, and a last round of applause virtual for you.
Thank
you very much.
Thank you.